Okay, once again we're looking at our voluntary daylighting system, and we have a closed loop sensor and we have a light that it is controlling 0 to 10 volts. I've put an assortment of light meters on the table, and the first thing I'm going to do is check to see what the daylight leakage in this space is. 0.6, 0.2, 0.4, plenty dark enough to proceed. Now I'm going to let the lights mellow out and come to reference illuminance, and then we're going to read all these light meters and log it as I slowly open the garage door. Now, what we're actually doing here, and I hate to say this, but it's true, is we're cheating. We've covered fenestration. We have a big roll-up door. We use that big roll-up door to calibrate this system, to set up the daylighting system. Now remember, we're under automatic lumen maintenance here. We have set this up so that it is holding at a design level. All three meters have been positioned to read the same, and they're reading currently 21. It's fluctuating because we're under automatic lumen maintenance, but we're around 20 for our reference. So I'm going to collect this data, then I'm going to put it into a spreadsheet, then we're going to take a look at the graph, and we're going to see how well this system responds to a test, combined illumination in the area, when we set it up, when we're basically testing it with the same method that we used to set it up. So let's find out what happens. Alright, we've raised the door and lowered the door and collected our data off of these light meters. They all read about the same. We're using the same technique to test as we did to set up. So one would expect that we're going to get really good results doing this. But it is kind of cheating, and I'd like to point out that one of the big illuminating factors in this garage when I roll up the door is glare. Let's start by examining our plot, our printout for our voluntary daylighting system that we just set up. We ended up with a reference of 19, which was around the 20 that we've been measuring all along. Here we see our electric illumination decreasing as the sunlight comes in, and here we see our combined illumination. This is where our daylight equals our reference illumination, actually exceeds it. So you can see this is very tight. At no time does it drop below 19, and it's only a foot candle above out here according to our measurements, which we just take honestly and hope for the best. So, okay, so that's the approximate response of the combined illumination in the space, and then the electric would be similar. And then, of course, we would have our flat spot where this critter has run out of dimming. And let's take a look at that. There we are. So that's a pretty good approximation of the system's response. What are they really asking us for, however? What's the minimum response? Because when I say this is pretty tight, it's only a couple of foot candles above reference. And it actually runs out of dimming slightly before hitting our reference illuminance, coming in as daylight. 45-degree line, whatever's coming in as daylight will get added to the combined illumination. So while these things are not exact, this does give you a very good idea of how things work. We should have about a 2-foot candle gap there,
and we should have about a 2-foot candle gap here, and that's because the lights merely dimmed down and didn't shut off. But here's all the code is actually asking us for. They want a 75% illumination reduction. This is your electric illuminance at 150% of the reference, which was 20, so we're out here at 30. So you can see that as the daylight comes in, the combined illumination gets quite high. In fact, at reference, it's 150% of reference. Our partial daylight that we're taking between 75%, around 75%, we can see that's quite high. In fact, about 7-foot candles high. And this would still pass. This would still pass just fine, because this is their minimum requirements under the code for daylighting response. So at 150%, we only need a 75% illumination reduction. We'll talk more about this, and I'll set up an interactive graph, and we'll look at all of your code-mandated limits for setting up a continuously dimmed daylighting system.
Glare is direct sunlight entering an area such as this and reflecting off of surfaces. At least that's my unofficial definition. So this is glare, okay? The sun's coming in at an angle of incidence, and it's coming off, the sunlight's coming off, basically the majority of it at the angle of reflection, and you're seeing glare coming in and reflecting all over. And so this is a big problem for setting up daylighting systems, is you really want to mount your sensor where it's not affected by glare. You get a double whammy in a closed loop system, and we'll discuss this.